And we're going to be using something called the rational zero theorem in order to find all of the rational zeros of a polynomial. These are going to give us all of the possible zeros, and then from there we can narrow it down to figure out which ones actually work for a given polynomial. The first thing we need to do if we're doing this theorem is to make sure that our polynomial is in standard form. What that means is make sure all of your degrees are in descending order, the highest degree first, the lowest degree last. Then you're going to write down all of the factors of your constant, which should be at the very end of your polynomial. Write down all the factors of your leading coefficient, which should be at the beginning of the polynomial. And then we're going to divide the values of the constant factors and then dividing by the factors of the leading coefficient. This is going to be a lot of numbers, and we're going to include both the positive and the negative of those numbers. So if we had a constant of 10 and a leading coefficient of 3, one of those factors of 10 is 5. One of the factors of 3 is 3. We could do 5 over 3, or we could do negative 5 over 3. We're going to include both of those values. Then we're going to use synthetic division to determine the values for which this polynomial comes out to be 0. These are all of the rational roots. So what we're doing right now is figuring out a list of possible roots, then we'll figure out what the actual roots are, because not all of them will work. So first things first, the degree of a polynomial, which is the highest exponent in that polynomial, that tells you how many roots the polynomial is going to have. If your highest degree is 2, you're only going to cross the graph 2 times. If your highest degree is 8, you'll have 8 roots. So it all depends on that highest degree. Again, P, we're using the letter P as the factors of the constant, and we're using the letter Q as the factors of the leading coefficient. So first let's figure out P. We have f of x equals 3x to the 4th minus 2x squared plus 6x minus 10. Our constant is that term at the number at the very end. We're just going to worry about the 10. We're not going to worry about the negative, because again, we're including the plus and the minus. So for P, we're doing P over Q. Our factors of 10 are 1, 2, 5, and 10. And we're going to divide by the factors of Q, which are the factors of our leading coefficient. The leading coefficient is 3. The factors of 3 are 1 and 3, and we need to include that plus or minus. So now let's go ahead and simplify each of these. I'm going to do 1 divided by 1, 2 divided by 1, 5 divided by 1, and so on. That leaves us with plus or minus, and I'm going to make my list. 1 divided by 1 is 1. 2 divided by 1 is 2, 5 divided by 1 is 5, 10 divided by 1 is 10. Then 1 divided by 3 is 1/3, 2 divided by 3 is 2/3, 5 divided by 3 is 5/3, and 10 divided by 3 is 10/3. So all of these, the positive and the negative of each of these numbers, could possibly be the zeros of this polynomial. But notice the highest degree here is 4. So only 4 of these are actually going to work. We're going to worry about which ones they are later. Right now we're just listing all of the possible ones. Let's look at another one. G of x equals 5 minus 7x to the 4th plus 3x squared plus x minus 20. This one's not currently in standard form, so what I'm going to do is I'm going to put it in standard form first, and then I'll figure out what my P and Q are. So in standard form, the highest degree goes first. That's this degree of 4. So I have negative 7x to the 4th plus 3x squared plus x. And then I have 2 constants that I can combine. So I have 5 minus 20, which is negative 15. So now P over Q is going to be plus or minus some fraction. For P, I need the constant, the factors of the constant, which would be 1, 3, 5, and 15. Q would be the factors of this negative 7, which are 1 and 7. Again, we're just worrying about 1 and 7, not the negatives. So now when we simplify each one, we have 1, 3, 5, 15, 1 over 7, 3 over 7, 5 over 7, and 15 over 7. If any of these fractions could be simplified, we would definitely simplify them, but in this case they can't be. Those are all of the possible factors of this polynomial.